All right, I'm going to erase this from the last lesson. I'm going to look at section 11.2 in this lesson. So let's go ahead and look at that. 11.2, it's on page 219 in your book. Okay, remember how we've been talking about how numbers can, or how things can be organized? Well, today we're going to look at number sets, okay? Numbers can also be divided into tangible sets or groupings in order to help us refer to multiple numbers as a group. If you'll recall back, we learned about fractions. We started referring to non-fractional amounts greater than 0 as whole numbers. Okay, that was really a number set, a name given to describe numbers with specific characteristics. So, in other words, a number that's not a fraction and it's more than 0. It's a whole number. Okay, so last chapter we learned about negative numbers and positive numbers. Those are also number sets. So let's take a look today at a few common sets used to describe numbers with specific attributes. As you continue to study math and examine in more depth how God causes this universe to operate, you'll find these sets useful in referring to numbers with specific properties. For example, if you need a whole number to answer a problem, if you need a whole number answer to a problem, you can just say whole number rather than saying you need a non-fractional amount greater than 0. It's easier to say a whole number. Now, I'm just going to go ahead and suggest that you might want to take some notes on this one. Just anything, a note card, anything you want, but I would highly suggest taking notes, okay? Because we're going to talk about different sets of numbers. So first, let's look at positive and negative. So like we saw in the last chapter, numbers can be thought of in terms of whether they're positive or negative. Notice that a number is either positive or negative. It can't be both. And 0 is in a class all its own. It's neither positive nor negative. You might want to know that. All right, turn the page here. We're on page 220. All right, so up at the top, you've got positive number set, any number greater than 0. Then you have a negative number set, any number less than 0. So let's look at integers and its subsets. Now, sometimes we don't care if a number is positive or negative. We only know we need a non-fractional amount. So rather than categorizing numbers by positive or negative, we could categorize them as fractional or whole. But wait a minute. Whole numbers are only positive. They start at 1. We need to have another name to describe non-fractional quantities in general, regardless of whether they're positive or negative. And we do. They're called integers. So that's what an integer is. Now let's look down. Right in the center of your page, you've got a big circle. That's your set of integers. Notice that those sets are enclosed in brackets. You see that? Now, brackets are just a common convention for representing a set. And then those 3 dots at the end and the 3 dots at the beginning just simply means that the numbers continue. Obviously, you can't write all those in there. And then notice you have a subset, whole, natural, and counting numbers. All right, let's read below it. So note that integers can be positive and negative. Positive and negative categorizes numbers based only on direction, positive or negative, while integer categorizes them based on type of quantity they represent. They're different organizational systems, much as pies and apples. Could be different organizational systems for recipes. On the other hand, every whole number is an integer. Whole numbers are a subset of integers. They are a smaller grouping within the same organizational system. So let's look at natural and counting numbers. And those are simply different names for whole numbers. They represent the same set. Some people include 0 in the set and others don't. In this course, we will treat 0 as a we treat whole, natural, and counting numbers starting at 1. So we do not count 0 in that for this course. Now there are still more ways we could subcategorize integers. Some integers can be divided by 2, others cannot. We call those that can be divided by 2 even, and those that can't be divided by 2 odd. Note that 0 is even as it can be divided by 2. We saw way back in section 4.4, because you can divide 0 divided by 2. You can't go the other way, but you can do 0 divided by 2. All right, look at the top of 221. So there you have another diagram. You've got the set integers, which can be positive or negative. And then you've got two subsets, an even and an odd. They're both integers. Now, you already know about prime numbers. Prime numbers are whole numbers that can't be divided by any whole number but themselves in 1. Notice that prime numbers are really a subset of whole numbers, which are a subset of integers. So look at that one right in the middle of 221. You've got the whole set of integers. Remember, those are positive or negative numbers, whole numbers. And then you've got a subset of whole, natural, and counting numbers. Remember, those start at 1 and go up. And then you have yet another subset within that one of prime numbers. Okay? Now, why do we organize numbers? Now, number sets help us refer to numbers with specific properties. For example, remember back to when we factored numbers in order to find their least common multiple or their greatest common factor? We had to keep factoring until we got to all the prime numbers, a fancy name for a whole number greater than 1 that cannot be divided evenly by any whole number except itself in 1. Okay, so then they did 24, they did 156, they worked down those factor trees till they get to its prime factors. 24 is expressed as a product of its prime factors, 2 times 2 times 2 times 3. And then 156, 2 times 2 times 3 times 13. Now, aren't you glad we could say prime factors instead of factors that are whole numbers greater than 1 that cannot be divided evenly by any whole number except themselves in 1? So you just say prime numbers instead. All right, let's turn the page. Let's read this keeping perspective. So why are there so many types of numbers? Well, because God created a complex universe. It takes a lot of different types of numbers even to begin to describe it. Biblical principles also give us a framework for understanding why we can organize numbers into sets. For one, God's consistency in holding all things together enables us to have confidence that certain quantities will consistently have specific properties. For example, odd quantities will not be divisible by 2. If quantities did not operate consistently, grouping numbers by their properties would be pretty useless. Also, if our minds are generated by chance, we would have no reason to suppose that we could make logical sets and subsets. The Bible makes it clear we are not here by chance. We were carefully fashioned by a loving Creator. We are able to observe the characteristics of numbers because the God who created all things also created us capable of observing and naming His creation. Look at that verse from Ephesians 2:10. This is our pastor's favorite verse. For we are His workmanship, created in Christ Jesus unto good works, which God hath before ordained that we should walk in them. So what God created us for good works. And some of those good works means that we have to think. Most of them we do. All right, let's look at worksheet 11.2 right quick. I have a surprise. It's only one page. 11.2 is just the front. Okay, so it says you can use the calculator just on number 4 at the bottom. So on part 1, A, B, C, and D, you're just going to circle all the sets listed that can be used to describe that given number. Okay, look back in your book if you need to. Pardon me. On part 2, it says, make flashcards for each of the different number sets mentioned in 11.2. It's important to get familiar with them so you'll recognize the terminology when you see it. I highly suggest getting a note card, an index card, and making a flashcard for each one of those. They're right up there on number 1. Whole numbers, prime numbers, integers, negative numbers, positive numbers. Make note cards for each one of those. I highly suggest that. Now, part 3 and 4 are just practice from what we've been doing, okay? So I think I will grade this page. It should be pretty easy. If you're not understanding, you need a little bit more explanation, just let me know. Otherwise, that is all of this lesson.